A 3-volt motor. A staple of toys and small electronics projects everywhere. But what if you could take something this small and actually turn it into a useful tool? My goal here is simple. Squeeze as much performance as possible out of this tiny motor. Not by adding more power, but by changing the design around it. I've made 2 3D printed blower designs to test, and even though they use the exact same components, they behave completely differently. Our setup is nothing fancy. A single 18650 cell, a 1S Type-C BMS board, a basic speed controller, and of course our 180 DC motor. All cheap, all easy to get. The whole point here is getting the most out of minimal hardware, because at this scale, everything matters. Tolerances, housing shape, clearances, even how the air exits the system play a huge role in performance. Small changes here don't give small results, they completely change the outcome of how this thing behaves. The first version is my proof of concept. Let's just say it's got character. The handle is small, the barrel is tighter, and honestly, the electronics mounting is kind of hacked together. But it works way better than it probably should. The second version is cleaner, smoother, has a much better handle, and uses a wider outlet to move air. And going into this, I was pretty confident this would be the better design, but that's not exactly what happens. My first idea for testing was using smoke to visualize airflow. And right away you can see both of these are capable of pulling in a stream from a decent distance, which is already kind of surprising for something this small. But when you flip it around and actually use it to blow, that's where the difference really shows. The first design packs a much stronger punch, and it's more focused. It really drives into the embers and stokes them. The second design definitely moves more air overall, but it's softer, more spread out. It feeds the flame but not as aggressively. And at this point I started realizing this wasn't just about airflow. The smoke test is great for showing airflow, but what about actual force? So here I set up a simple test using sawdust and distance. Something repeatable, something measurable. The first design was able to move sawdust consistently at about 20 inches. Which, honestly, is pretty impressive for a motor this small. The refined design struggled to move anything past about 10 inches. And that was kind of unexpected, a little bit disappointed. It's clearly moving more air, but it's not delivering it with the same speed or impact force. So the question is, why? So what's actually happening here? What's the real difference between these two designs? The first version is basically just a tight, circular housing with the motor mounted right in the center. The second uses more of a snail shell design where the casing expands to allow smoother airflow out of the nozzle. They're also using different impeller designs. But the biggest difference comes down to this. The first design is tighter. The gap between the impeller and the housing is just enough to move air effectively while still maintaining pressure. The second design allows more airflow, but it's too open. So instead of building pressure, it loses that energy before the air even exits. So what's the takeaway here? Honestly, I'm kind of blown away by how much performance you can get out of a small 180 motor. This thing is actually usable. I've been using it to clean off my desk and workspace, and it works well. But more importantly, this shows just how much design matters. The distance between the impeller and the housing wall, something that seems minor, completely changes the performance. Same motor, same power, totally different results. So this is just the starting point. Next, I'm stepping up to a more powerful motor and redesigning the housing to try and get the best of both worlds, pressure and airflow. From there, nozzles, dust collection, even a solder fume extractor, really a limitless application. There's a lot more to explore here. But I'm curious, what would you optimize next? Or what would you use something like this for? And if you want to build one for yourself, I'll have the files up on my printables. All the links for parts for this design are Amazon affiliate links. And as always, happy printing.